All right, 3.2. Let's go back to transition state theory really quickly here. Which of the following represents the transition state for the reaction of ethyl bromide with methoxide? So the implication here is that this is an SN2 reaction. Let's draw out what this looks like first. It's just sort of a stick figure kind of a situation that's going on here. So, or stick figure, a bond line structure here. So we have ethyl bromide. So what does ethyl bromide look like? We've got, well, let's start with methoxide. This actually makes more sense to do it this way. So H3CO minus, this is your MEO minus, right? That's what that is. That's your methoxide. Notice how there's a negative charge on the oxygen. You want to guess what the role of that negative charge is? Is it the electrophile or the nucleophile? It's rich, electron rich. It is the nucleophile. Yeah, this is the nucleophilic position, this atom that's right here. Okay, we're going to react it with ethyl bromide. All right, so what does ethyl bromide look like? So it's ethyl group with a Br attached to it. Okay, so again, we apply our convention. Our leaving group is bromine. Bromine is always touching the electrophilic position that's right here. So we can fundamentally think about this as being methoxide is going to react with that ethyl bromide. And you can probably imagine what's going to happen here. The methoxide oxygen is going to attack the blue carbon. And as it attacks the blue carbon, we're going to symbolize that it is the leaving group is going away. We symbolize it by breaking that bond like this. So we can kind of see sort of what this sort of looks like in this case. This is, I guess the product would be, kind of think about the product as looking OCH3, and then you have some Br minus. The bottom line is that you've got to show in your mechanism, you got to show in the transition state the nucleophile attacking, coming in, and the leaving group leaving. All right, so let's look through some of our examples, some of our possibilities here. So let's look at A really quickly. A is you have your methoxide is coming in, it's attacking the blue carbon. We'll apply the color scheme to this. So oxygen is attacking the blue carbon, and the leaving group is going away. That looks really similar to what's going on here, but this isn't our answer. Why isn't this our answer? Does anybody know? Not because the BR, this is okay. The shape and the positioning of everything is good. The problem is the electrophile. Look at the electrophile. The formula is what? The electrophile should be ethyl bromide. What do we have here? How many carbons do we have? And this one right here? Just one carbon. It's not ethyl, it's what? Methyl. So this can't be our transition state. Nope, can't possibly be it. So A is out. Okay, let's look at B. B looks like it could be on the right track, except for, what do we notice about B? Well, look at the position of the nucleophile, the electrophile, and the leaving group. They're steric crowding, right? And they're 90 degrees. So they're not, one's not coming in and the other one's leaving. It's like one's coming in and one's going up. That's not what's happening in this transition state. So B is out. Yes, ma'am. Yeah, give me 2 seconds. Let me finish this up and I'll talk to you. All right, C. Do we like C? Look at the nucleophile. Oxygen's coming in. Carbon's right there. Bromine's going away. What do we think about C? I mean, it looks positioned right. The nucleophile and the leaving group look pretty good. Now let's look at the electrophile. How many carbons should be in the electrophilic position? Or how many carbons should be in the electrophile? Should be 2 of them. Do we see that? 1, 2. Hey, this might be it right here. Okay, so this could be our answer. Let's look at what's going on with D. Do we like D? What's the problem with D? 90-degree angle between the nucleophile and the leaving group, right? So if you don't see that, let's highlight these really quickly. And the leaving group goes away like this. So even though there's an ethyl kind of component in here, a 2-carbon unit, doesn't matter. The positioning of the atoms doesn't look good. Therefore, this is our best answer in this case.